geometric sequence. Suppose we are given this pattern of numbers. We have 3, 6, 12, 24, dash dash, 400, 200, 100, dash dash. How can we get the next two numbers in each case? Now for the first one, you realize that a subsequent number is found by multiplying the preceding number by 2. So we have 3 times 2 gives us 6, times 2 gives us 12, times 2 gives us 24. So this one will be given by taking 24 times 2, giving us 48. 48 times 2 will give us 96 for this dash. In the second case, it's like the subsequent numbers found by multiplying this preceding number by half. So we shall have 400 times half, giving us 200, times half, giving us 100. So 100 times half will give us 50 for this dash, and 50 times half will give us 25 for this dash. The pattern of numbers that you get by multiplying a number by a constant so as to get the next number is what we call geometric sequence. And the first number in that pattern is what we call the first term, and it's always denoted by small letter a. So in this case, this is our first term, this is our second term, third term, fourth term, fifth term, and this is the sixth term here. The number that you keep multiplying by the term so that you get the next term is what we call the common ratio, and it's denoted by a small letter r. Suppose we are required to get a term which is so large, like we want the 1000th term. You realize that it will be so cumbersome for us to keep multiplying by 2 until we get to the 1000th term. That's why we use this formula, or that's why we have this formula for calculating the nth term of a geometric sequence. And the formula is a r raised to power n minus 1, where a is the first term, r is the common ratio, and n is the term we are interested in. So if we concentrate on the first example here, you realize that our first term a is 3, and the common ratio can be calculated by taking a term divided by the preceding term, meaning 6 divided by 3, or 12 divided by 6, or 24 divided by 12, and that will give you 2. And indeed, this is the one we have been multiplying by to get the next term. Now in the second example here, our first term is 400, that's our a, and the common ratio will be gotten by taking 200 divided by 400, or 100 divided by 200, and that will still give you the same result, half. Now, using this formula that we have up here, assuming we had not done manually and gotten the fifth and sixth term in the first sequence, how can we get the fifth and the sixth term using the formula that we have here? We will realize that for us to get the fifth term, we shall say fifth term is equal to a times r raised to power 5 minus 1. Why 5? 5 because we are looking for the fifth term. So it will be 5 minus 1, because in the formula, we take the term we are interested in minus 1. That will give us the value to use as the power for r, power of r. So that means this will simplify to ar raised to power 4. But remember, we know our a, it is 3, the first term, and our common ratio has been calculated and we found it to be 2. So we can write this as 3 times 2 raised to power 4. And we know 2 raised to power 4 means this 4 is only affecting 2, it's not affecting 3, so it's only 2 that is raised to power 4. This means 2 times 2 times 2 times 2 times 3, and if you simplify that, it will be 3 times 16, and that gives us 48. And indeed, this is the term that we got that occupies the 5th position. Then the 6th term will also be found in that similar manner. We shall say 6th term is equal to AR raised to power 5, because we are looking for the 6th term. The power here will be 6 minus 1, which is 5, and that is equal to our first term is 3. We have it here. The common ratio is 2, so it will be 3 times 2 raised to power 5. And as I said, it's only 2 that is raised to power 5. So if you simplify that, you will get that being equal to 3 times 32, and that gives you 96. Now we have some questions to work here. We have to find the 4th and 5th terms of the following sequences. Starting with the first one, you realize we are looking for terms, and therefore the formula that we have up here holds. This is the formula we shall use because it's the one that we use to get a term. Starting with the first one, we shall say nth term is equal to AR raised to power n minus 1. This is the formula. Now, considering the first question we have here, the first term is 1, and the common ratio is gotten by taking 4 divided by 1, or 16 divided by 4, and that will give you 4 as the common ratio. Having these two, then we can calculate the 4th term by saying 4th term is equal to 1, that's our A, times R. R is 4, we have calculated it here, times 4 raised to power 4 minus 1, because we are looking for the 4th term. N is 4. 4 minus 1 gives us 3, so this will be 4 raised to power 3. And if you simplify that, it will give you 64, because this is 4 times 4 times 4, giving us 64 times 1. That gives us 64 still. So the 4th term is 64. What about the 5th term? We shall work it out in that similar manner. We say the 5th term is equal to A is the first term, which is 1, times the common ratio, which is 4, we had calculated here, raised to power 5 minus 1, because we are looking for the 5th term. So the power here will be 5 minus 1, and that is 4. This means 1 times 4 times 4 times 4 times 4, and that gives us 256. In the second question, you realize that our first term is 1000, so A is 1000, and the common ratio is given by 200 divided by 1000, and that gives us 0.2. Now the 4th term will be given by first term, which is 1000, times the common ratio, which is 0.2 raised to power 3. The reason why we are having power 3 is because our n is 4. 4 minus 1 gives us 3. So that's equal to 8. If you simplify that, you'll get the answer equal to 8. The 5th term will equally be calculated by using the same formula. So our A is 1000 still, times our common ratio is 0.2 raised to power 4, because we are looking for the 5th term, so the power will be 5 minus 1. That means raised to power 4. And if you do that, you get the answer 1.6.